Once water reaches a river system, fluvial processes begin. These include erosion and transport of suspended sediments and bedload. Flowing water wears down river banks, and the material is carried as bedload or suspended in the water column. A river erodes in 4 ways: corrasion, attrition, solution, and hydraulic action.
Rivers can erode in 4 different ways. To start with, I'll draw your river bed. There it is. Surface of the river there. On your river bed, there are countless millions of pebbles being moved along the river towards the river mouth. As they go, the pebbles get reduced in size. They get reduced in size through frequent collisions. There's 2 pebbles colliding. This process is called attrition. What it does, it knocks all the sharp edges off the pebbles. The pebbles end up perfectly smooth. Some people say, oh, look at the pebble, it's water smooth. It's not. It's attrition that's knocked all the pebbles together. The second kind of erosion is corrasion. It's where the pebble bounces on the river bed. This deepens the river. It's the process of vertical erosion. What we've got here is a classic limestone shelf in the Yoredale series. The waterfall behind is bringing water down and it's swirling onto the shelves. As it swirls, it brings sand, gravel, fine material, and it's this swirling action that creates these potholes. So the gravel is actually scouring the rock out. This is absolutely classic corrasion. It's riverbed lowering, vertical erosion. A third kind of erosion, which is harder to illustrate because it's going on at an atomic level, is corrasion. Remember, your river is weakly acid, a weak carbonic acid usually in the rivers. This weak carbonic acid will attack any limestones down here and they will dissolve particles into the river. If it's limestone, this will then be carried away in solution as calcium bicarbonate. Another one that's very hard to illustrate, the 4th kind of erosion, is the hydraulic action. It's the shear force of the water blasting water at the rock. It's the sheer force of the water that breaks up the rock. Three kinds of erosion are happening here. Hydraulic action, that's virtually the splash of the water hitting the rock. There's corrasion. The water is actually carrying grit, pebbles, even massive boulders are coming down. They smack into the floor, create a huge plunge pool. The third kind of erosion is attrition. That's where the boulders knock against each other and totally alter the shape of the boulders. Stage is about transport. I think when you sit on a river bank and watch all the pebbles there, it's hard to believe that every single one of them is slowly moving towards the sea. Sometimes in times of flood they move a darn sight faster. But there's 4 things that can actually move a pebble or a particle along a riverbed. Here's our river flowing in that direction. The sheer force of the river on the pebble pushes it along. This is called traction. Some books you might even see they use the word shuffle, because every pebble on the riverbed is shuffling along. The next thing is that sometimes this current actually gets behind the pebble and lifts it up. We have suspended pebbles. which then crash back down onto the riverbed. This process is called saltation. Sometimes, with the very small particles, they actually get lifted up, and I have to draw a very small particle in, and we'll put a nice sail on because they go off sailing down the river. This is suspension. On very, very high flows of water, the river will actually turn brown with suspended material, so you'll be able to see this yourself. The fourth kind of transport is solution, but it's done at an atomic level, so it's somewhere in there. Swaledale has essentially two basic rock types. This one at 350 million years ago is your Carboniferous limestone. This one about 310 million years ago. Totally different. You can see it's a gritstone. South Yorkshire, these would be the millstone grits. But the river picks them up, rolls them along, knocks them off, and this is why they are perfectly smooth. This is the big difference between glacial erosion and river erosion. The rivers smooth all the rocks off as they roll along the riverbed. Remember, rolling along the riverbed is traction. When some of the small particles actually bounce up into there, that's saltation. So this is going to be a familiar pattern all the way along the riverbed. Every single pebble is rolling along the riverbed towards the sea.
The Hjulström curve describes erosion, transportation and depositional processes in relation to water velocity and particle size. The upper curve shows the critical erosion velocity in centimetres per second as a function of particle size. The lower curve shows the deposition velocity, again as a function of particle size. Both axes are logarithmic, increasing in multiples of 10. For cohesive sediments, such as clay particles, erosion velocity increases with decreasing grain size as cohesive forces become stronger. The largest particle that a river is able to carry at any moment is termed its competence.
Clay minerals are incredibly complex, and there are many of them. In Devon and Cornwall, this felspar breakdown gives you a rock you may have heard of, kaolin, because it's the basis of bone china. It's a white, light clay, but there are many other clays. The most important one is illite. You'll find that in most of the clays as a mineral. All the minerals are flat, platy minerals, and they stick together. Try and imagine you've got two plates of glass with a little bit of water in it between the two plates. The surface tension between the two glass plates is enough to pull the plates together. That is exactly what is happening between these plates of calcium aluminium silicates. Many of the bonds between these minerals have not been completed. So you actually also have electrostatic forces pulling the particles together. This is called cohesion. It's this cohesion that when the particles are actually floating in the water, this electrostatic forces pull the particles together and cause the clay to flocculate and sink to the bottom of the riverbed when the current slackens off.